We are working on enhancing the Connect 4 project from the YByte Python curriculum available at www.ybyte.in. Um, this is an interesting game, but look, in our project, the computer is not yet smart. Now we are going to build some enhancements later on where we'll give some smartness to the computer. But as of now, the computer is quite, let's say, naive and basically just plays in any available column, which means that it's actually quite easy to defeat. However, we can turn tables and we can create a twist. I call this anti-connect 4. This is really something, I'm not sure if this is really a game of this sort, but it's an interesting game anyway, especially in this situation. So I'm just going to twist my rules a little bit. I'm going to say, okay, look, if the computer gets 4 in a row, like always, computer wins. So, no change there. However, if the player gets 4 in a row, then also the computer wins. The only way the player wins is if the board gets fully occupied with no one, let's say, completing. When I say no one winning, I mean no one completing 4 in a row. So think about it. This is quite an interesting twist to the game. Now you have to play in a way that you don't win, but you must prevent computer from also winning. Let's see this. It's quite, like I said, quite interesting. Okay, so here my computer has made one move. I'll just play here. Now I'm just trying to, basically I'm trying not to win, but I must make sure the computer also doesn't win, right? So if let's say I keep going, all right, so let me just block this. Uh, Computer is as always playing randomly. So now I would want to play, okay, I would want to prevent this because computer might win here. So I will prevent this. I can play this, I think. I can now play this. So basically I just want to make sure I am not winning. But before that, I must make sure computer doesn't win. So, here I think I can play here. Okay. This is okay. I think I can. Okay. So let me just put something. Okay. So I definitely wouldn't want to play here because that will make me lose. In fact, we can try that. If I do this, notice I lost because I got 4 in a row. So now it says computer won. Notice, let's play this once again. I hope you notice there's an A over here, which kind of states that this is an anti-game, so be careful. This is quite safe. Now, so, okay, so computer can win here. I must block this, and thankfully I am not winning here, right? But okay, so computer won this by, just winning the game legitimately. Let's try this yet. Let's try this yet again. Now you can clearly see it's become a lot harder for the player to win, although in the many attempts, let's try this once again. Now you can clearly see that it has become a lot harder for the player to win now, even though the computer is playing with the same, let's say, naiveness. In the several tries that I did win once, so there is hope. Let me just try that. Okay, so I will block my computer all the time, but I just want to make sure I am not winning. So this is okay, I guess. I should block this guy. Let me try to win this time round. Okay, so let me just sort of waste some chances here. Okay, so this is very tricky because computer might, okay, so it did not win it here. That's where it helps that it's not smart, right? So it did not win this. Okay, lucky escape for me. But here the computer. Now I wouldn't want to play here because this will make me win, and in other words, computer win. So let's try this. Let's hope the computer eventually puts a coin over there. I think I can go and play this. This is nice. I'll block the computer. Okay, good. So it's put it here. This gives me an opening. I can play my card here. I wouldn't want to play here because again, I will end up losing. So I think this is here a safe bet. All right. So this time I have some hope. I should block the computer in all ways. So here I think, okay, so I wouldn't want to put it here because that will make me lose again. So let me just try to put the coin over here. Clearly you see that this has become very challenging now. You really have to think what's going on. Let me try to, if I put it here, okay, I think this oh no, I wouldn't put it here. I will play it, in fact, here. Computer plays here, and I think I am at the verge of winning. Finally, I got one victory. Notice this game is now complete. It tells me player won because basically I prevented the computer from winning and I did not win. But you can clearly see how hard this has become. So much more harder than the original version where we had to play with the regular rules because right now the computer is not playing in any smartness. It's just randomly sprinkling the coins. So very, very interesting, this variation. Now, how do we get this in our program? Well, the idea is not at. So I get back to my code over here. the way we are going to do this is I'm going to define a variable called anti-C4, which I'm going to set to true when I'm playing the anti game. So I just go and say, look, let me just set this, for example, anti C4 to say true. So let's just make it true. So, which means that I'm going to play the anti game. Now, in order for my player to know that we are playing the anti game, I'm going to put an A over here like we had done. And the way we do that is by just the way I do that is by just putting putting another turtle which goes and writes over here, let's say an A. So that tells me that look, this is anti connect 4, and this be careful because there's an A over here, right? So that's just the use of the binary the boolean variable. Put a turtle over here. Now the real game changes when we look at how the let's say the winners are calculated. So I so let's look at the let's get back to the code where we decide who is winning. Basically, that's part of the player function as well as the play C function, the computer playing function. In the player function, I check for the winner. If one has won, then I display that the player has won. But then it depends on, whether I'm playing the anti game or the, let's say, the normal game, right? So, which means that I'm going to have to check here. Look, game over is true for sure. If, any one winner has been found, the game gets over. However, I check here if say anti C4, that means the anti game is going on. Well, in this case, definitely then remember if we get 4 in a row for red, it's actually the computer wins, let's say. And since the computer has won, I can go and write the result as say a value of 2. Because remember, in the right result function, 2 represented computer. So basically, computer has won because the player completed, let's say, 4 in a row. On the other hand, if the anti C4 is not set, which means else over here, so that's the regular game, I will do the exact same thing as earlier. So let's just put this a regular, right? Now, remember, let's say I do not have a winner, but the situation is such that my entire board has gotten over. Now, in that case, again, it depends on whether we are playing the inverted rules or the regular rules. So I'm going to just add a condition over here, say elif, let's just say all done. Now we have not written this function yet, but basically this function is going to tell me if the entire board has been, let's say, occupied. So I just say, well, if all done, then, well, the game definitely has to get over. In fact, this must have been, we should have added this earlier itself, but that's okay. Question now is if I'm playing anti C4. So if anti say C4, um, if anti C4, then in that case, it's the player who has won. So I can just go and write these results again. So because anti C4, the game has gotten over with nobody winning, right? And hence the player has won. Of course, if none of this happens, then, the turn goes to 2. So of course, I'm getting an error on this right now, all done, because we have not written this function. We'll do this in a moment. However, before doing that, I'll go to the play C function. In fact, similar changes have to happen. Basically, I ask myself if check winner is, say, check winner 2 is true, which is the regular situation. Nothing changes here. Game over is true. Computer wins. And we write the result as 2 because computer has won. On the other hand, we ask ourselves again the same question. If, let's say, so I put an elif here, all done. So if all done, which means that board is completely over, nobody has won it. In this case, again, the game does get true. So a game over does get true, does get over. However, remember, it's the player who wins. So I just put here, for example, say print, let's say player wins. Player wins, and of course, as a result, I write the result as 1, and everything else remains the same. Notice if I come into the else, really nothing changes, right? So, okay, so there's a small catch here. I do this only if anti C4 is set up, right? So anti C4. Okay, so if anti C4 is true, then if the game, let's say, if the board gets completely over, then the player wins. And you can see that if anti C4 is, let's say, not set, then everything kind of works as usual. Now, all we need to do is to define this function all done. This is not hard at all. So I just do it here. Let's say I just go and say def all done. Now, the idea behind this function is, is the board completely occupied? And how do we know if the board is completely occupied? Well, remember, if the board is completely occupied, there'll be no zeros on the list called board because every item that you put in red or blue either becomes 1 or 2. So, this is kind of straightforward. I can just go and write answer is equal to false. So I start with a false, and I just go and check every row. So for kk, say kk in range, say range n rows, you know, if 0 in board, let's say kk, so if there's a 0 in there, then I can break, which means that there is still some room left in the board is not fully done, and hence the answer will return as false. Else I will set the answer. Think about it. If I find a 0 in the board, it means that the board is not fully done, and hence I return a false. If I don't find any 0 at all, then I set answer to true. So I do it for every row, and in effect I end up doing for every for the entire board, right? And having done this, I will just go and say return, let's say answer. Now this is really all we need. We expect the game to be working now. So when I, let's say, run this, you notice now that I see an A over here indicating that we are playing, in the anti mode, right? So let's try to, let's try some scenarios here. So say if I complete my 4, so let me just try to get my 4. In fact, the game gets over. You notice the game is over, but it says computer 1 because really the player has done the 4. So I let the computer hopefully win this from here. Okay, so still not winning, still not winning, but I'm avoiding my victory over here, so rather my defeat actually from here. But never mind, I'll just continue to play till the computer actually wins this. Sometimes it's so frustrating. It's right here, victory should happen, but refuses to take the chance, right? So anyway, let's try to, so I'm not going to play here because that completes my 4. I play here, so there's now 2 chances for computer to win. I can play here safely. Yes, indeed, the computer won. That's exactly what I wanted. Now let's try again. This time it's so this time round looks like finally I have some chance of defeating the computer. I will play, let's say, here. All right, let me block the computer from here. Okay, so this was quite risky because in fact computer could have played in 1. I will, however, now try to block it. Okay, so this is good. I would, maybe I can play here, and it's okay. So I need to block now. Think so far so good. It can't complete this here. It can't. Here is also good. I can think I can play here and not win anything. So should I play? All right, let me just try to play over here. Okay, so this is looking good so far. Now it's my real chance at winning. If I must block this. If I block this, look, the player won. So finally I got one, after a lot of effort. This is a board where I have won the game basically because I could prevent the computer from winning. Very, very, very interesting twist. See how the entire game changed with just one twist of rules. And in the code, because the code is structured in a nice way, we could implement this quite nicely. I hope you enjoyed this, made you think. This is why we believe at Ybyte that programming is fun because we can do so many things with it. Channelizing our energy through activities like this makes us think about the logic very, very clearly, implement ideas, and have fun while we learn. Look at our website because that is how we learn Python programming. Take care. Thank you so much. Bye bye.